So in the previous video, we talked about why this example fits an analysis of variance hypothesis test, and we also went through to show you how to get the StatCrunch output that's provided here in the notes. So at this point, we're going to focus on going through the actual analysis and coming to whatever conclusions we can about these house prices. So the first thing we need to do is to find out if there's evidence to suggest that the average prices of houses differ in these areas. We're going to start with just that, because if there is no differences, then I don't need to figure out which are different and how. So the first thing we're going to do is just the hypothesis test itself, and then see if we need to look at any confidence intervals. So once we know we are doing an analysis of variance hypothesis test, I'm going to know the structure of my null and alternative hypothesis. My null hypothesis is going to be that all of the population means are equal to each other. Here we had the four groups that we were comparing, so I'm going to have four means that I'm going to use here. So my mean for Burlington will be the same as my mean for Edgewood, will be the same as my mean for Florence, will be the same as my mean for Independence. My alternative hypothesis, again, unlike in previous modules, is a little bit more vague. It is just going to be that at least one of those population means is different. Now for our second step, that has stayed the same and has not changed here. It is still going to be that we are going to reject the null hypothesis and instead believe the alternative hypothesis if our p-value is less than alpha. And here we were told to use a 0.1 or 10% significance level. In step 3 is where we first do our conditions and then our test statistic. So our first condition is knowing that we have independent random samples. So why is this example independent? So remember, we always assume that they are independent until we know otherwise. For us to know otherwise, I would have to know that sampling a certain house in Burlington would now ask me to kind of sample a certain house in Edgewood, Florence, and Independence. All it says here is we took a random sample of the houses listed by Sipsey-Klein. So it does not give me any reason to believe that if I sampled a certain house in one area, that forced me to sample a certain house in another. So again, there's going to be no known reason to match the houses across the areas. And it does say they were random samples of those listed by Sipsey-Klein. So for those that don't know, that's a certain realty group in the Cincinnati area. At least from what I know, I don't know there's any bias associated with that particular realtor. So I'm going to assume that the random part is also okay. The second condition is I need to know that all my populations are normally distributed. Now, in our first example, we had all the histograms to look at to actually see that they were normal. In this example, it just told us in the problem to assume. So again, that's the two different ways that you could know if they're normal, either having the histograms to look at to see if they look unimodal and symmetric, or just to be told in the problem that we're going to assume it to be true. Our last condition is one that we do assume, but we're going to go ahead and write it to make sure we know what we are assuming. It is that all of the population standard deviations are unknown but equal to each other. The other part of step 3 is to do our test statistic. So here is now when we need StatCrunch output. So here is where we're going to focus, is on this ANOVA table here. And notice here I actually did delete that F statistic that we actually saw in the StatCrunch video. So I need to go back here and use this MS column to help me calculate my F. And the good news is they're right in the order we divide them. So it's this one divided by this one. So we have the numbers to use to calculate my F. And that would give me an F of about 3.87. Again, the reason why that test statistic we still calculate is to remember that this test statistic, whatever this number is, drives what p-value I'm actually going to get in step 4. So what I mean by that, if this number were to change, then my p-value is also going to change. So that's why we are still going to calculate that test statistic each time. So step 4 is to get our p-value, which is just going to come here from StatCrunch itself. And so there's my p-value of 0.0154. So going back up now to our step 2, is that p-value less than 0.1? Yes, because 0.01 is less than 0.1. So we will end up here rejecting the null hypothesis and believe in the alternative. So then the last part of our hypothesis test is to write out that interpretation, which follows the same structure that we are used to. So we're going to start with our significance level, which was 0.1. Because we rejected the null hypothesis, there is our statistically significant evidence. To support. Now our last part is the alternative hypothesis, but in words, not symbols. So that at least one population mean house price in these 4 areas is different. So that answers our first question here of, is there evidence to suggest that the average prices of houses differ in these areas? Yes, there is evidence of that. Now we need to follow up the question here with, if so, which are different and how? So remember, this is where this alternative is very vague, so which makes our interpretation here feel less than satisfying, because yay, at least one of them is different. Okay, but which ones are different, and then how are they different? So if I was someone looking for a house, do I know of areas that are similar in price, or areas that are more expensive, or areas that are cheaper? I would want to know, how are these different? So this is finally where those confidence intervals are important. Recall here first that we did a 90% confidence interval simply because we had that 10% significance level here. So that 10% and 90% are complements of each other, so that's why we're going to use that. Notice here we actually get 6 confidence intervals. We have 3 here, 2 here, and 1 here. Now first also remember what I'm looking for when I look at the lower and the upper. What I'm looking for is where are differences. So differences are going to exist for me as long as the interval does not include 0. So let's go through each of these intervals and see if 0 is included or not. So if I go from 25.7 to 175, does that include 0? Nope, that one's all positive, so that's going to be a useful interval for me to look at. If I look at the next one, a negative 28 to a positive 120, does that one include 0? This time it does, because I went from a negative number to a positive number. That's what I mean when I say it crosses 0, is if I go from a negative number to a positive number. So there's really no significant difference for this group. Looking at my next one, I go from negative 52 to a positive 88. Again, negative to a positive, so I cross 0. So there's no significant difference between them. Now moving on to the Edgewood columns here. We have negative 131 to positive 21. Again, that one includes 0, so there's no significant difference. Looking at our next one here, we go from a negative 155 to a negative 10. This one, since both of them are negative, does not include 0, so it is going to be one that I want to look at. And finally, our last interval from a negative 100 to positive 43. That one, since it's negative to positive, includes 0, so there's no significant difference. So what this really means for me, out of all 6 of these intervals, really only 2 are useful to me. This is one that shows a difference, and then this is one that shows a difference. So these are the only 2 confidence intervals that I'm actually going to need to interpret. So let's think about what those intervals are telling me before I try to write out my interpretation. So looking at our first interval here, let's first get our order of subtraction. So when it says Burlington subtracted from Edgewood, that means the order of subtraction here for me is Edgewood minus Burlington. When I look at those numbers, we're getting all positive numbers. So to get all positive numbers, which one has to be bigger? The first number has to be bigger in order for me to get positive numbers. So the Edgewood's going to have a higher price than Burlington. And notice that our data agrees with that. For our other interval that had the star, purple star here by it, is Edgewood subtracted from Independence. So that means my order of subtraction is Independence minus Edgewood. This time our interval is entirely negative. So to get negative values, which one of these things has to be higher? The first or the second? The second one has to be bigger. That's what it would mean for me to get a negative number. So our Edgewood has a higher mean than Independence, which notice again our data agrees. Now that we know the directions, we're going to use the actual numbers in our interpretation. As we get ready to do that, I want to remind you that the values were in thousands of dollars. So when I actually look at this 25, this is $25,736. So that's where I'm going to be pulling these numbers from. So the first one's going to have $25,000 to about $175,000. And let's write out these interpretations together. So I am going to be 90% confident, because that was the confidence level we chose based upon our significance level, that our population mean house price in Edgewood is between, now going back and looking at our numbers here, 25,000-ish to 175,000-ish, higher than in Burlington. So the $25,736 and $175,406 more than in Burlington. Now before we do the other interval, just a reminder, this is not how much house prices are, this is how much higher the mean house price is in Edgewood than in Burlington. So how much more on average would you pay if you got a house in Edgewood than in Burlington? And then our only other confidence interval here that did not include 0 was our Edgewood and Independence. Edgewood is higher than Independence. That's all that negative told me, so I can again kind of take off those negative signs, and then I'm going to flip the numbers around where the smaller number is actually first. So then in Edgewood is also between $10,786 and $155,252 more than in Independence. So even though this example had 6 different confidence intervals, only 2 of them ended up not including 0, so those are really the only 2 that give me evidence of a difference. All right, hopefully at this point you feel comfortable with analysis of variance. Please don't hesitate to contact me with questions.